Hi, my name is Mike Holt, and I want to thank you for taking the time to watch this DVD. This is going to be a very interesting and a challenging subject, and we're going to be understanding the basic principles of motor control. But before we get into that, I'd just like to take a moment and give a dedication and thank God for giving me the opportunity to do what I do, to help people, and I hope that I'm making proud of the work that we're going to go here. Before we get actually speaking about the topic, I want to introduce our panel members, and we have four different individuals. We have Steve Iron. All right, Steve, tell us a little about yourself.
Mike, I'm from Rapid City, South Dakota, where I went through a formal apprenticeship program, worked as an electrician, as electrical contractor, in electrical wholesale, and then I have taught full-time at a technical school for 19 years, and doing my own classes in exam prep and continuing ed, as well as doing some editorial work to help you out when I'm able to.
Yeah, you've been on the video team many times, and the details of Steve will be inside the textbook. Take a look in there. You'll see a picture and a bio and information how to contact Steve directly if that's something you need to do. Our next team member is going to be Eric Stromberg. Eric, you've been on our team a long time as well. Tell us about yourself.
Well, I started out working as an apprentice electrician while I was going to school. Continued going through school, got a degree in electrical engineering. The job market wasn't great back then, so what I did was I got the opportunity to be an electronic technician for 7 years. And then in 1989, started work for Dow Chemical as an electrical engineer. And then met you about 2000, started teaching.
So you have the background as electrician, then
Electronic technician.
Electronic engineering, and then of course you've been with me now for 8 years doing all the different things that we're talking about code, so you really got the package together. Our next guest is going to be Dan Webb. And Dan, tell us about yourself.
I'm an electrical supervisor for a timber products company in Medford, Oregon. I've worked in wood products industries most of my working days. Come up through the ranks, started out as basically a millwright, made it up through electrical supervisor. I teach continued education classes in Oregon. I also teach apprenticeship program.
Okay, appreciate that. Our next guest is going to be Dennis Carlson. Dennis, tell us about yourself.
I'm Dennis Carlson, and been in the trade for probably 28 years, and electrician, residential wireman, electrician, worked on residential, commercial, industrial, and for the past 19 years I've been craft training manager over the electrical division for TIC, the industrial company.
When did you start doing video team members with me? Eric started in 2000.
It's probably been 2002, 2003,
And
somewhere
Steve,
in there.
how long?
2002.
2002. So Eric, you're the veteran right now inside here. All right, our last guest, and he's really not going to be a team member, is going to be Mike Horvath. He's our graphic illustrator. He's the one that actually wrote this particular textbook. And Mike, you've been with me for how long now?
About 25 years.
Yeah, we've been doing this a long time. We argue and we fight code and we fight graphics, and we're a great team. We've done a great
That's the
job.
fun.
We've
That's
done a
the
lot of
fun.
great products. So Mike is the one who actually wrote this textbook. This is the only textbook that I didn't write. Mike is the author of this, so I'm not responsible for anything if it goes wrong.
I was afraid you were going to say
The
that.
graphics and everything. I'm talking about me and Mike and the team players and how I play here. You know, this is kind of a strange experience for me because I'm usually the expert. I mean, I write on the code and the calculations, and I'm the guy I'm not the expert in motor control. I mean, I'm an electrician, and I'm like all these other guys. Mike was a journeyman electrician, master electrician. I mean, everybody here has followed the same route, and I'm a journeyman electrician, master electrician. And you know what I think is funny is a lot of guys look at us in the field, I'm sure every one of us, and they can't relate to us thinking that we were electricians and we were doing that kind of stuff. And it's you wish you could communicate that. I know people, particularly with me, like, I don't think he was an electrician. So, but what I didn't have, and I still don't have, is I don't have the strength and motor control. So if you watch me and I look like I'm a little stupid here, and I'm asking dumb questions, I'm asking questions that maybe some of you would be asking, and some of your instructors are going to think, well, I know that. I would have thought he know that. So I'm going to be upfront honest with you. I'm not the expert. I'm the facilitator here, but I think we're all going to work together for the purposes of really explaining motor control. And I'm going to go back to our team members, and I'm going to ask them to kind of communicate their first experience with motor control. And I'll give you a couple of my experiences first. The first of my experience, anything had to do with a thermostat. I mean, you have what? A green, a white, a yellow, and a red wire. And then you have this device. And I didn't understand how to connect it in the first place, and I didn't know what the wires did. That was my first experience. And I remember a guy taking a piece of cardboard, and he drew something out, and he showed the W and the R and the G, and he took the thing out, and he showed me there's a letter. There's a W, there's R, a G, and what was it, white, green, yellow. And I'm like, but I didn't understand what was going on. My next experience with controls, let's see, it was a two-stage thermostat. Hey, now I know how to hook up a thermostat. Years later, and I'm working in construction. I wasn't in the service, and I didn't do, controls. And my job was to hook up a two-stage thermostat for an air conditioning unit. Now, on a service call, now I'm a service electrician, just became a service electrician, didn't have any service call experience. 4 hours I'm screwing around, hooking up 5 wires to a thermostat. And I never, ever got it to work after 4 hours. And I'll be honest, I got fired because of that. So I love motor control. You can see this. I mean, and that's not my full extent, but that my fear, I sweated. Here I'm a journeyman electrician now. I didn't have the experience. I'm in the field, and I'm freaking out. So, but that's my experience. Let's start with you, Steve. Now, your approach, your experience was different than mine, though.
Yeah, it was different in that I had the training and so in the classroom before I was actually put into the field to hook one up, but still we have the common characteristics of the drawing a diagram on the cardboard. That's kind of what happens out on the job is, we got to kind of put it into perspective of what do we actually got out here and where are all the parts and how do they hook together.
So, but you weren't intimidated. You were just a little not sure.
Yeah, just a little not sure. I kind of.
But you had the concepts.
I had the concepts.
What was going to go on. Eric?
Well, I had the concepts, but then it got to the practical problem of field devices. And I don't know if the camera can maybe come up on this. I saw the schematics, but if I look at this button right here, I don't see how to hook up anything. No?
Yeah?
And then, but if I
Keep going.
If I see this button right here, what we have is I can see the contacts through this plexiglass. And so the problem that I had when I started with motor control is that I knew how the schematics were, but I didn't know how to hook the equipment together because I couldn't see the actual parts within them. And I just didn't want to, you talk about feeling, I didn't want to blow anything up. I didn't want to be responsible for damaging equipment.
So now, you understand the concepts, and you were concerned about damaging it, but you just didn't trust that you understood exactly what it was physically doing, electrically doing. And so you were just, you weren't comfortable to turn it on.
Right.
You want to get a continuity tester out there or something. You want to be able to check things out to make sure this is doing, this is normally open, this is normally closed, this is doing something.
Exactly.
Dan, your experience?
Mine's probably a little backwards than most because I started out as a millwright, which does all the mechanical, and I had equipment that wasn't working, and I kind of fumbled around until I figured out how to make it work electrically. When I became an apprentice, then it was like somebody had it down in writing. It's that's what we've been doing. So that's just great, for me.
And Dan? Dennis?
Well, when I first really started dealing with it was with the conveyor belt system, and they had emergency pull cord switches and zero speed switches and belt alignment switches and all these different switches on one diagram, and it was just frustrating to not be able to understand how everything kind of tied together and controlled this one motor that controlled this one belt, and it was frustrating. Very frustrating.
Let's ask a question. You guys know what we're going to be covering in the next couple DVDs. When you get done with this book, this DVD, you watch. Oh, by the way, let me talk about this. You want to watch a DVD. Don't sit there and try to follow the book with it. Just sit back, watch the DVD, get the big picture, get the scope and the understanding. Then take your textbook and read the textbook, work the examples, work the practice questions, go through the whole thing and say, because in the DVD, I don't cover everything in the textbook. Also in the DVD, I might have a couple slides or a couple graphics extra that might not be in the textbook. So be a little patient if you see an extra graphic. Don't let that throw you off. You watch a DVD, you're relaxing, you get your textbook, you follow through it. Then I strongly suggest that you watch a DVD again, because then it's like, oh, now it makes sense what Dan was talking about. Oh, now I understand when Dennis said this and why Eric commented. And then you can put it together. But if they watch a DVD, they read the textbook with some of the stuff not covered, if they do the practice question, if they watch a DVD again, how are they going to feel in the field, Dennis, given to your same situation? Are they going to be like still overwhelmed?
In some aspects, but I think once they start getting into it and a little bit more repetition, then I think it'll be.
Is it going to take
it'll become
repetition to really be able to have this thing applicable? I mean, if you go one day, one time, and then you don't do it again for a year, and then
Oh
all
yeah,
of
oh yeah, big time. You have to do it several times, over and over and over.
Steve, what are your thoughts on there?
Yeah, I agree. There needs to be repetition to, if you just wire up a circuit once and you're a year away from it, you're going to have to come back and revisit that.
You know, let's talk about this. One of the things we hope to achieve in this textbook, not so much a DVD, but in the textbook, is to give you the tools on some common applications. Like Steve said, you know, if you don't do this repetitively, every time you start it again, you're like, what the heck was that supposed to be? The textbook will have a section that, how do you reverse a single-phase motor? How do you hook up the three-phase motor? How do you make a two-wire control circuit? So we'll give you a section, you kind of go back and like, oh yeah, and then take that, and Eric, as you show the switches have a number, the number 2 and a 3, and it's like, okay, I remember this. So don't feel like you have to be able to remember it all, but know that there's a resource. This is to give you the concept, to show you that we're all stressed out, we're all not sure all the time, but if you take one step at a time and you get yourself back into it again, even if you've been away from it a while, you're going to be able to put it together. Eric, last
And
comment?
I've got to say that the thing that's absolutely exceptional about this book are the graphics. And in motor control, the thing that's very, very difficult is being able to get a concept of what's going on. And Mike Culbreth has done such an outstanding job of building these graphics that make everything so clear and easy that this is going to become a wonderful reference tool when you look back on it and you say, hey, look, that's in the book. I'm going to get it. It's right here.
That's a key. It's reference. Now, also, this textbook is not going to cover everything. We're just covering the basics. We're just trying to get you started. So don't feel like this is going to be everything you need. But it should be a great reference for you. All right, let's get into some motor control basics. When beginning to study in motor controls are basically different kinds of switches that turn things on and off both manually and automatically. Some of you guys said this morning in breakfast, you were talking, who was the one that was talking about this, said to you that it was just basically switches? Dennis, I think you're the one?
Well, it's just one of those things that when I first started out, and it was, like I said, frustrating, a gentleman turned around and he told me, he goes, it's just like a switch with a light bulb.
In other words, the
single
load
pole
is the light
switch.
bulb,
Yeah.
the switch is you're turning it on.
And you just got to remember that whenever you look at a ladder diagram or an elementary diagram, it's in its de-energized state.
We're going to talk more about that. So some basic principles is that you're trying to turn on a load, a light bulb,
Right.
and you're using a switch. I mean, think about it. It's an electrical circuit, so you got to be able to close the switch to turn on the load. And the question is, how do you close the switch? Is it done through a computer? Is it going to be done manually? Is it going to be done automatically? Is it going to be done through some kind of external sensor? So that's what we're going to get into. Let's take a look at Chapter 1. Basic principles of motor controls, definitions, abbreviations, symbols, common control equipment devices, and as well as symbols. All right, let's get into it. The concepts of motor control, we're going to be talking about in Unit 1. Motor control language, and the types of wiring diagrams that are used. First thing is the principles. Motor control circuits and equipment permit the use of smaller conductors, cables, and raceways. Control equipment can also have a much lower ampere rating. Here's what we have. We have this motor. Now, this motor is going to be, in this case here, I don't know what it's going to be. I can't say what size fuses, but let's just assume this was 60 amp fuses. Well, if we're trying to control this by a push button over here, because we're trying to have some kind of convenient control, instead of me running wires and putting a 60 amp disconnect over here, I'm able to use some small control wires that can control, this case here happens to be a motor starter, so we can use smaller wires for controls, smaller raceways, and we also have a lot of control to be able to turn this motor on or to turn the motor off. Is there a particular size wire that's a common practice, guys? Dan, what do you guys use for like a control circuit if it's not computer control?
We generally use 16 AWG.
So your push buttons would be 16, would be, control wiring.
Yes.
Eric, do you use a larger wire in yours?
We typically use 12 gauge because of distances, unless it's part of an assembly and it's already 14.
Okay, so it's a lot smaller than the power conductors
Right.
involved with the motor. Either way, however, and we'll talk about those details as to how do you size it. But the concept and the principle of controls is you want to be able to take a load, and that doesn't have to be a motor, obviously. You want to take a load, and you want to be able to do something with the load. You might want to tie it with a computer that when this load starts, it starts a process, and then we want to go with this one, and then we want to do this, and we might want to provide some signaling. Okay, well, is the load on, and how much is it drawing, and is there water in that container, or the liquid? What's the level of that? And that affects, well, how much grain, and we want to make sure that we have a mixture, that we have so much of this versus this and this, and we want to be able to mix it up, and then you got to wait till it all fills up, and then you got to turn it. You can see there's a million combinations, and what an exciting opportunity to be able to control things through, and eventually, once you get the basic controls operating, and Dan, I think you guys, is it almost all with computers? Your
Yes,
controls?
we have computer PLC control on all of our equipment.
Yeah, so I mean, we'll talk about that. You're in the sawmill industry. So this, the wood comes in, it gets cut up, all this stuff gets processed, and a lot of these things gets in a process. So in order for all of this to work, the controls offer flexibility. We need to make sure that it says that in the book. You have flexibility. You are able to manage and manipulate things and make things work as a cohesive system, or simply turn something on, turn it off. But it's all turning it on and off, but it's a matter of sensing it, reacting to it, signaling it, putting it together with smaller conductors than it would take. All right, let's go on a little further. Motor control circuits can be of lower voltages than the motor to make it safer. So here's an example where we have a 480 volt. Don't worry about all the details here. You're going to be able to read this later on. But this is line 1, line 2, line 3. This is the power coming into the motor, and it's going to be 480 volts. We can take a voltmeter between line 1 and line 2. It's 480 volts. But maybe if we kind of go back a couple slides, we don't want this guy working on 480 volts right here, because right now in this example, if this was a 480 volt application, we're tying in to this line 1 right here on this one fuse, and now, well, this one happens to be, well, it's one fuse. I'm not sure where the voltage is going to be, but let's just say this was 480, then this push button will be 480. Now, do you guys, Eric, do you guys keep your control voltages at a certain voltage at Dow Chemical, or whatever it is whatever it is? Is there a
Right,
practice?
our control voltages are typically 120 volts.
Okay, so therefore, if that is your practice, if you got a 480 volt application, like what we have here, then you're going to put a transformer, step it down from 480 down to 120, then we can have lower voltage. I'm making an assumption. We all are making this assumption. We assume that you understand basic electrical theory. What I mean by that, you know what Ohm's law is. You know what a series circuit is. You know how they operate. You know the laws of series circuits. You know the laws of parallel circuits. You understand magnetism, electromagnetic coils, relays. And you need to have a strong foundation. If you don't have that foundation, I'm not trying to sell you something. You need to get our theory book. You need to get the theory DVD. You need to complete that first. It isn't going to be fair to you to sit down, watch this DVD, go to the textbook, and you don't even realize that you're uncomfortable. You don't know why. What it is because you don't have the foundation and the basic that it takes to get to this level. Take a look at this graphic right here. If you look at this graphic here, some of the things that you should be able to understand already. You should understand that this is a transformer and the concepts of transformers, and you should understand what an overcurrent protection device is, what a fuse is, what a circuit breaker is, how they operate, how electrical circuits operate, how voltmeters operate. All these are fundamental givens that we are assuming, not how how that circuit worked, but understand the fundamentals of electricity. Steve?
Just on the safety side, Mike, there are a lot of circuits that a majority of them probably are lower voltage using a like the 120 that you're showing or a PLC, but there are circuits out there that do use the 480 volt control. So we want to really caution the guys to be careful and test that voltage and know what they're working on. I worked on old sawmills that were all 480 volt controls, and
Okay.
they're a widowmaker.
And now, and with controls, you could use any voltage you want to use. It's a matter of design. I mean, you say, hey, we got 40 there. We're not going to put a transformer. We're just going to go with the 40 volts. And then somebody's like, no, we want to go to 120. And some people say, hey, we got computers here. We're going to be able to drop that down to much lower voltages because we're using electronics to make it happen. So Steve is bringing out, and we'll talk a lot about this later on as we go along, and it has to do with electrical safety. Make sure it's safe. All right, let's move on. All right, controls consist of computerized systems, solid-state logic controls, programmable logic controllers. We are not going to be talking about logic, programmable controllers, or any of that. So right at the beginning, and you're like, well, wait a minute now. What's the sense of me getting a motor control book or a DVD today in whatever year this is, and it's not covering that stuff? Nope. No, we're covering the fundamental and basics. And I checked with you guys, the experts, when we talked about last night and this morning. Am I right? This is, Dan, you work with PLCs every day, don't you?
Yeah.
That's your life.
I do.
Now,
we have PLCs plus computer interfaces that have graphic controls, but the basic relay ladder logic start-stop station is used in our PLCs. I mean, that concept is used throughout everything we do.
how do I, as an electrician, take this course, learn the basics, get an understanding? How do I get into the area of PLCs? How do I learn that and be able to then, I mean, how do I do that? How do I do as an electrician?
Well, you need to walk before you can run, and
Wow.
using this relay ladder logic and understanding controls and the interface devices and whatnot, you know, photo eyes, float switches, you need to understand that before you can bring them into a PLC and then do the...
But where do I get the classes? Because you call my call. No, we don't have it. Well, I thought you had everything. Okay, we don't have the books. We don't have the DVDs. We don't have the classes. So how do the guys watch this DVD get into programmable controllers? The engineers or the electricians? Or
There is a couple other companies out there that do offer motor controls, and it's a hands-on class where they have simulators that you can actually work with, and then also PLC classes.
But I'm saying the PLC classes.
Yeah, you can get industry classes. Sometimes trade schools will have a
Right.
class on PLCs, but there are some subtle differences from manufacturer to manufacturer. A lot of the manufacturers do have their own
So
training
Allen
classes.
Bradley is
Allen
going to
Bradley
have
training
a class,
yeah.
and they're going to have a training program and explain how their ladder logic works and how their products interface. So the key is this. If you want to get in programmable controllers, or PLCs, programmable logic controllers, then you're going to need to get with the manufacturers and find out about their classes. And some of you watching this DVD is interested in that. And that's where you're going to get to the next stage you're going to go to. All right, let's move on. Motor control equipment. There are two basic designs of motor control equipment, NEMA and IEC. NEMA is the National Electrical Manufacturers Association. It's going to be heavy-duty equipment. Maybe some of you guys can get one of those NEMA devices ready for us to take a look at, and the camera can zoom in tight when we get to that. It's used in a broad range of applications, and it's commonly used in North America. And that's going to be NEMA. Let's take a look at IEC controls. Is the International Electrical Technical Commission. It's less expensive, smaller in size, tailored for specific applications or specific requirements, widely used in Europe and Asia. All right, let's take a look at it. So the one on the left of the two, that would be your NEMA. Look at the big wire.
Well, this is NEMA.
Yeah, it's my left, I'm sorry.
Okay.
The camera's left. That would be NEMA. You can see the big wire on there. You can see the equipment. Now, the one on the right is going to be IEC. Smaller, basically equivalent, same size. Give me some feedback, guys, as to, Eric, you're an international company. Do you guys use one standard versus the other, or whatever you guys can
we
buy?
use whatever standard the country calls for. I like to say that IEC is built for use and NEMA is built for abuse. So with NEMA, you have a 100 amp contactor, put 120 amps through it all day, no problem. IEC, put 103 amps through it, you buy a new contactor. And so it all boils down to knowing what the application is, knowing what you're doing, and applying products intelligently, and you'll be fine.
Dan, what do you guys use, NEMA or IEC?
Everything new we put in, because I work in the mill environment, industrial, we try to stay with NEMA because we do abuse our equipment as much as we can.
Okay. All right. Dennis?
NEMA, typically NEMA. I mean, some of the newer equipment you're going to see IEC, but It's
Steve, when you were teaching and when you were out there, what do you think?
Well, when I was wiring more NEMA, but anymore it's hard on the smaller sizes to even get NEMA, and the IEC is so cost competitive. But one thing that's really brings us down, like Eric was saying, I've seen a video done by one of the fuse companies showing a IEC type of contactor being subjected to fault current in excess of its rating, and it just vaporizes. Just
Okay.
vaporizes. So showing the importance of using a low peak fuse to
Okay.
protect them.
All right. Point is, there's different standards. The NEMA standard, IEC standard. You kind of got the feedback. We don't even really know any more than that, but let's move on. Let's now talk about language, electrical symbols, words, line diagrams that explains the operation of the motor control circuit. You know what? I'm not quite sure whether this is the right name, motor control, because we might not be controlling motors. Right? We might be actually having signaling. We might be like turning on a light or an alarm. So really, this is more of controls. We might be controlling lighting. We might be controlling motors. We might be controlling processes. So I'm not sure if I like the word motor control. I'm going to try to work on controls and signaling as we go along. The symbols represent devices, power conductors, control conductors, and conductor connections as well as terminals. Types of control circuits would be ladder diagrams, connection diagrams, pictorial diagrams. All right, let's talk about what we just were saying, all those words. This is a diagram, and it's called a ladder diagram. And the reason it's called a ladder diagram because we have line 1 on the left, we have line 2 on the right, and if we ran line 1 all the way down, line 2 all the way down, and we ran line 1 all the way down, we could now go ahead and make a connection from line 1 to line 2 and put another set of controls here that could do something else. So we're basically connecting with it. So now these are some symbols. We'll talk about this is a stop button. Oh, how do I know that? Well, because it says stop. This is a start button. Again, it says start. Now you got some contacts here, which we'll discuss a little bit more, and then you have some other things. We're not going to worry about that right now. But this, what you're looking at, is a ladder diagram. It's also called a line diagram or an elementary diagram. It's representing the function of the control circuit and associated devices. Again, I don't want you getting too detailed right now. I just want you to like, oh, that's a ladder diagram. You don't know what it means, but you can say, that's a ladder diagram. That's all I'm looking for right now, so relax. Let's take a look at a connection diagram. Now we had the ladder diagram. Now we have a connection diagram. And for convenience purposes, we put some numbers on this connection point. That's connection point 1, that's connection point 2, connection point 3. And then we have this start, stop, and that's going to show connection to point 1, connection point 2, and 3. So this is a connection diagram. Again, not trying to have you read it, just try to say it. Okay, I understand what a ladder diagram looks like. Okay, let's take a look at this. I understand what a connection diagram looks like. All right, let's move on to the next one. Now, pictorial. Okay, well, this wire here, we'll call that terminal point 1. That connects over to line 1. And then we have a contact here. We haven't talked about contacts yet, so I'm not going to get into detail. I want to, but I can't. Let's just say this is a pictorial diagram showing you kind of like, this is something like, Dennis, that you kind of created, where you actually put this together. I mean, you put your little contactor together, and then you have your start, stop button. So this would be something, Steve, you do like in a lab, right?
Right.
This is actually run this wire here and put this wire there and put this wire here, connect the wire there. Well, then that's what it looks like pictorially. In reality, the start, stop button might be who knows where it's going to be, but pictorially, we can see how it all fits together. And the next one is going to be hand-drawn diagrams. This is the one I enjoy the most. I think we all kind of like, okay, because I think a hand-drawn diagram, when you put it in the field, is because you don't have this page with all the stuff. You start with a blank page and say, okay, here's a light, here's the neutral, here's the hot wire, here's the switch, close, okay, got that. Okay, now let's add the next element and the next element. So take a look here. You kind of draw this out, and you kind of go on a piece of cardboard and a piece of keel or on the floor of a concrete slab, you know what I mean? And then you kind of like draw it out. So the different ways. Let's review this again. ladder diagrams, connection diagrams, pictorials, hand-drawn. Now, hand-drawn is kind of obvious. We know that we do that in the field. Pictorial is probably something you're going to show in a book. Like you were saying, Eric, these are great pictures you can see. The schematic diagrams or the connection diagrams, that's what you're going to see, what, on the manufacturer's literature?
Yeah.
And then where do you see the ladder diagrams?
Engineer, from the engineer typically.
So that would be in the engineering plans. Now, Dan, is that what you use, the ladder diagrams for programmable controllers?
The ladder diagram is what we use 99% of the time for hardwired as well as for relay ladder logic.
Okay. You know, if you feel compelled, if you want to, you might want to stop the DVD, say, hey, that wasn't too bad. Then stop the DVD right now. Take a break. Go back, read Unit 1. Work out the practice questions in Unit 1. You might want to say, you know what, I'm going to just rewind the DVD again. So you decide whether you want to watch the whole DVD, whether you read the unit or the units, or whether you want to do one unit at a time. You're the control. How would you guys do it personally? Let me tell you how I would do it. I was watching this. I watched the DVD. I'm thinking, that's easy. I'm not that intimidated. I have the basic concept. These guys give me some confidence. I think I would read the unit again, work out the practice questions, and I'd watch the DVD again. That's the way I would do it, because I know how my brain thinks. I like to take a piece at a time, okay, master that, and then if I'm confused, then I'd be able to see that part and not wait till I'm overwhelmed. But everybody's different. How would you guys, Steve?
Yeah, I think it'd be real good to, like you say, go to the book and then do those questions now, and that way it'll really kind of help internalize what you've covered already. If they do the questions, stop and think about it before they go on to more material.
Eric?
Well, to me, learning's like a staircase. I mean, you learn a little bit of philosophy, and then you put it in practice. You learn a little bit of philosophy, put it in practice, a little bit of philosophy, put it in practice. So it's a repetitious cycle. That's just the best way of learning.
And if you have somebody you know that you can review Unit 1 with also and ask them some questions, an instructor or maybe somebody in the field who has more experience, Dan?
Yeah, these graphics are so great. I think go into the book, and once you learn this basic building block, then you can grow from there.
Probably watching the DVD and at the same time using the book and going
Okay.
through the book. And then, at least then I could turn around and stop the DVD.
I gotcha.
And if there's something else more in the book itself, I could stop and read it. And then I could either rewind the DVD or continue going forward.
And I do need to remind everybody watching DVD that we're not covering everything in the book in the DVD, because there's a lot of content that we just can't cover in the DVD that you're going to have to read, and then your practice questions takes you there. All right, you decide. You might want to put this on pause, do whatever you think is the best thing to do, or continue on. Let's go on now to Unit number 2, definitions, abbreviations, and symbols. All right, let's go into definitions of control terminology first. It's real important. Now, we're not going to be covering any definitions in the DVD. There's a huge number of definitions. So you're going to have to take a couple minutes